Okay, children, so now let us see question number 12.1. Here it says find the range of values of x for which x square plus x plus 1 upon x square plus 2 is less than equal to 1 by 3, x being real. Okay, so here what we have to do is, whenever you got a question like this where you have to find the range and inequality is there, so in that case first you check the denominator. You should check the values of x for which denominator is becoming 0. So here clearly this denominator will be never 0. Okay, for any value you take any real number and this will never be 0. Okay, and next you have to see whether this is always positive or not. Okay, so here this is always positive and there's no real number for which it's getting 0, so good for us. So what we can do in that case, we don't have to exclude any real number, okay, from here, and we can simply proceed. So here denominator we have this which is always positive, and there's no such value of x for which is becoming 0, so simply we got this. Now we'll multiply both the side by, because we want to remove this from x square plus 2 from denominator, so we'll multiply both the side by x square plus 2. So in that way we get this. Yes, sign does not change because we are multiplying by positive. We know that x square plus 2 is always positive, so sign, direction of sign does not change. Okay, now simplify this. Okay, then you get 2x square plus 3x plus 1 less than equal to 0. Okay, now middle term, okay, factorization, factorize it, you get 2x plus 1 into x plus 1. Now what you have to do is, here you can see here coefficient is 1, so good for you. Here coefficient is 2, so this 2 has to be taken out as common. So once you take out as common, then you get x plus half in bracket x plus 1, okay, less than equal to 0. Now what you do, next step, divide both the side by 2, okay, plus 2, so sign is not going to change, direction, okay, and we get x, okay, and this plus has to be written in minus. Okay, so x minus minus 1, okay, for this, and x minus minus half for this. Okay, so you try to write whenever you have got plus, so first write it in this minus. Okay, if it is already minus, then you don't have to do anything, but if it is in plus, then you have to write it in this way. Okay, x minus something, x minus something. So, and you should try to write in ascending order. Okay, like minus 1, then minus half is greater than minus 1. Done. Once you have done till here, what you do, draw a number line. Okay, minus infinity to infinity. Okay, and then mark these numbers, minus 1, minus half. So here minus 1, minus half is marked. Okay, we have got only these two numbers. Yes, so when you are making this semicircle type, so this will continue till infinity. Okay, and this from minus half till minus 1 only, and from minus 1 till minus infinity. Done. Now how to decide that? I have to write minus, I have to write plus, or plus, how to decide that? So what you do is, what I have done is, here if you see, here it is minus half, 0 lies in this interval. Yes, 0 lies in this interval. Yes, this interval 0. Yes, so take that 0 in place of x over here. Replace here x by 0. Okay, so when I replace x by 0, so I get 0 minus minus 1, that means plus 1, 0 minus minus plus, that means I get 1 into half. Yes, 1 into half means half. So what I'm getting a positive value. Yes, I'm getting a positive value. That's why I will write plus over here. Once I wrote plus over here, then this will be negative. Okay, then after that plus. So alternatively I have to go. Okay, so this is how we have put. Now, but we are looking for only those values of x for which this left hand side is less than equal to 0. Less than equal to 0. That means negative. Yes, or it should be 0. So this expression will be negative for this interval. Okay, this expression will be negative for all the values of x which are lying between minus 1 and minus half. Okay, you can see negative. When this expression is getting negative, when you are taking any value between -1 and -half. Okay, so this any value from this interval will satisfy this expression. Here equal to is also there, less than equal to, that means it should be also equal to 0 also. So we are looking for those values also for which it becomes 0. So it is getting 0 for which value? For -1 and -half. Okay, so that means I have to include -1 and -half also. So all the real numbers from -1 till -half will satisfy this expression. So here value of x, okay, is greater than equal to -1 and less than equal to -half. Okay, and x belongs to real number. Okay, done. So this is how you do. Okay, so range, so range of this x, so range of the values of x, okay, is this -half till -half. Okay, -1 till -half. Now number 2, here it says solve x square plus 6x minus 11 upon x plus 3 less than -1. Okay, so as I told you in the first question, we have to, for this inequality type question, first we have to check. Okay, we have to check whether check for those values of x for where denominator is getting 0. So clearly for x equal to -3, denominator will get 0. Yes, getting it. And for some values of x it will be positive and for some value it will be negative. Okay, so when we are solving this, we will not do cross multiplication or not. Okay, we will not try to remove this from the denominator. Okay, but one thing we'll do is we will exclude x equal to -3. Okay, because we cannot consider that, because for that denominator will become 0. Okay, so in denominator we have x plus 3, which is not always positive. Okay, and for x equal to -3 it is 0, that is x plus 3 will be 0 for x equal to -3. Yes, so we assume that x belongs to real but x is not equal to -3. Okay, that means x equal to -3 is excluded from here. Now we copy that question. Okay, now from the right hand side this minus will be taken to the left hand side. So you get x square plus 6x minus 11 upon x plus 3 plus 1. Okay, now what you do? LCM. Okay, LCM is taken, done. Now simplify it. So you get x square plus 7x minus 8 upon x plus 3 less than 0. Okay, in numerator you have got a quadratic expression. Okay, do the factorization. Okay, and you can write this as, once you factorize it, you can write this as x minus 1 into x plus 8 upon x plus 3 less than 0. Okay, now the thing is, we don't know the actual sign of x plus 3. It could be positive or negative depending on the values of x. Okay, so what I will do is, we will multiply and divide by this. Okay, x plus 3 only. Okay, so on the left we are multiplying and dividing by x plus 3 only. Okay, so in that way this direction of sign is not changing. Okay, there is no change in the value. Okay, so x minus 1, x plus 8 already there. Now what I'm doing, I'm multiplying x plus 3, whatever is in denominator I'm multiplying, and same, and down also I'm multiplying with the same thing. So here I get x plus 3 whole square. Now since it is a square, that means no matter what value you put for x, it will be always positive. Yes, but in total your left hand side is what? Less than 0. Yes, okay, so in total left hand side is 0, that means numerator is less than 0. Yes, numerator is less than 0. So x minus 1 into x plus 8 into x plus 3 is less than 0, since x plus 3 whole square is greater than 0. Okay, now as I told you in the previous, here plus should be written in minus. Okay, here already minus, so nothing, you don't have to do anything. So this x plus 8 can be written x minus minus 8, x plus 3 can be written x minus minus 3, and x minus 1 simply like that. And I had told you it should be in the ascending order also. So it minus 8 minus 3 1. Yes, minus 8 minus 3 1. So in ascending order. Then you will draw the number line. Done. Then you will write this on number line. So minus 8 minus 3 1. This minus 3 you can see over here. I'm not darken it, okay, completely. You can see that white portion is in middle, okay. So because this minus 3 is excluded, okay, this minus 3 is excluded, we cannot consider minus 3, because for minus 3 your denominator is getting 0, okay. That's why this minus 3, when I have put it, okay, here in white portion is there in middle, okay. Now now we have to decide which interval is positive, which interval is negative, okay. So it's always easy to take 0, okay. So let us see where does this 0 lie. So this 0 is in this interval minus 3 till 1, okay. So 0 is somewhere here, yes. So let us put 0 in place of x. So when I put 0, so it will become plus 8 plus 3 and minus 1, okay. So 8 into 3, 24, into minus 1 will be minus 24. It's a negative number, yes. So that means this interval is negative. So this is negative, so this will be positive. This is negative, so this is positive. This is positive, then this is negative. So done the marking. Now what you will do, but we are looking for those values of x for which this left hand side is less than 0. Means we are looking for only those values of x for which this will be negative, okay. So you can see in which interval this is negative, for this minus 3 to 1, okay, and anything you take less than minus 8, okay. So x should be less than minus 8, okay. Here equal to sign is not there, that's why 8 is not, minus 8 is not considered, because for minus 8 it's 0, okay. So equal to sign is not there, that's why here x should be less than minus 8, or x should be somewhere in between minus 3 and 1, okay. And here 1 is not included because equal to sign is not there, okay. And minus 3 is already rejected, okay, means excluded, we are not considering it, okay, because if you consider, then denominator will be 0. So the same thing you can write in this manner also. X belongs to, okay, this when you write in the open bracket, okay, this type round bracket, that means it's open interval, we call it, okay. In that case minus 8 comma minus 8, where this minus 8 is not included, okay. And this u means union means this or this, okay, means it's all x could be from here or here, okay. So this symbol is called union, and minus 3 comma 1, okay. So this same thing can be written in this, okay. Now we come to question number, okay, no number to this question. It has 6 marks. It had come in 2019, okay. Here it says find the range of x of the inequality. So what we will do is, as I told you, you have to check the denominator. You should look for the values of x for which denominator is getting 0, okay. And we should check if it's positive. If it's positive, good for us, we can simply cross multiply. There will be no change in the direction of the sign, okay. If it's positive for some number and it's negative for some number, so you will bring that number from the right to the left, and then you do the calculations. First we'll check whether it is 0 for any value. So here in denominator we have 3x square minus 2x minus 5 is equal to 3, okay, greater than 0, okay, and d is equal to greater than 0, okay. So when we were studying this about the sign of the expression, okay, so we had seen that whenever discriminant was greater than 0, okay, whenever discriminant was greater than 0, so in that case that expression was not always positive, okay. To some part it was positive, and for some part it was negative, depending on the sign of a, okay. So here a is positive, that means this expression will be positive for all the real values except for those for those real values lying between the roots, okay. So what we'll do, that means it has got roots, and that means we will get two values of x for which your denominator will get 0, yes. So first we'll find the root of this. So we find that when you evaluate this 3x square minus 2x minus 5, you do the factorization. Okay, so you will get that x plus 1 into 3x minus 5. So what you do, this 3 is over here, take it out as common, so you get 3 into x. I told you if it's plus then you have to write in minus, so 3 then x minus minus 1 into x minus 5 by 3. So you can see that if value of x is minus 1 or if the value of x is 5 by 3, okay, for these two values, for minus 1 and 5 by 3, your denominator will be 0. Yes. So what we'll do, we will assume that for this expression, x is a real number, but x is not minus 1 and x is not 5 by 3. Okay. Now come to here. Okay. Now bring this right hand side, whatever you have, minus half on the left. Okay. Take the LCM. Okay. That means simply cross multiplication will do. Okay, then simplify it, you get minus x square minus 2x plus 15, and down you you get this. Okay, you had already done the factorization for this. Okay, you had done over here, so simply write that. So you get this. Okay, and this becomes, and here you take out minus common, so you get minus x square plus 2x minus 15. Down you get 6 times x plus 1 x minus 5 by 3. Okay, now what you can do is, here you have got minus 1 upon 6. So what I can do is, I can multiply by 6, then this 6 will be removed, sign will remain same only, and when I multiply by minus both the side, then this sign will change. Okay, so by multiplying by minus 6 you get this. Okay, now this numerator is a quadratic expression, factorize it. So you have factorized, so you will get x minus 3 x plus 5, and down you get x plus 1 into x minus 5 by 3. Now this step is important. Okay, we had done in the previous question also. We know that x plus 1 x minus 5 by 3, it could be positive or negative. Yes, depending on the value of x. So what I'll do, in numerator I will multiply with whatever I have in the denominator, and down I'll take the square of it. Okay, so x minus 3, okay, and x plus 1. Okay, this x plus 1 is there, so up also I'm writing x plus 1, and down I'm making it x square. X plus 5, x plus 5. Here I have x minus 5 by 3, so x minus 5 by 3, and down I'm making it square. Now this left hand side expression on the left hand side is less than 0, but denominator will be always positive now. Oh yes, because your square will be positive, square will be positive. That means numerator has to be less than 0. Yes, so this implies that numerator is less than or equal to 0. Next step, I had told you that you should write in the ascending. Okay, and wherever you see plus, write it in minus. Okay, so that's why x minus 3, this x plus 1 becomes x minus minus 1, x plus 5, I can write x minus minus 5, x minus 5 by 3, this, done. Now write in ascending, so x minus minus 5, then minus 1, then 5 by 3, then 3. Yes. Now next work is to draw the number line, drawn. Yes. Now on number line you can see that this minus 1 and 5 by 3, I have not darkened it. Okay, not a solid circle. Okay, white portion, white is there. Yes, in center, because they are excluded. Okay, we cannot consider them. Okay, because for these two values denominator is getting 0. So minus 5, minus 1, 5 by 3, and 3, done. Now we will look for the signs, which interval will be positive, which will be negative. So easiest way to take the interval where 0 lies. Okay, so where is the 0? 0 is here in this interval. Yes, so let us put 0 in place of x. So when I put 0, I get plus 5 plus 1. That means if I multiply, I'll get positive over here. This is minus 5. Yes, this is minus 3. again minus minus positive, so I'm getting positive. Yes, so that's why this interval is positive, then this will be negative, this will be positive, this is positive, so this is negative, this is positive. Done. But we are looking for only those values of x for which your left hand side will be less than 0 or equal to 0. Okay, so for which it's less than 0. For this interval is less than 0, that means negative, and for this interval it is less than 0. Okay, and we have to include those values of x also for which it's 0. Okay, so see over here, for minus 5, okay, for minus 5 it is 0. Okay, for minus 5, if I put minus 5 over here, then the whole thing will become 0. So I have to take minus 5. Okay, that's why I'm making this bracket, okay, rectangular bracket. So minus 5 is included. For minus 1 it is 0. Okay, but I cannot take minus 1 because for minus 1 denominator will become 0. Okay, that's why minus 1 and the open this round bracket. Then union, then we'll write about this interval. Again 5 upon 3 cannot be taken because for this denominator is getting 0. And I will take 3 because for 3 it is 0. Okay, so this is how we get the range. This is the solution for the above inequality. Okay, now question number 14.1. If x be real, prove that the value of this cannot lie between 5 and 9. So for this type of question, what you have to do is you have to take this whole expression as equal to y, then cross multiply. Okay, then simplify it, bring it to one side. Okay, then what you'll see that this can be written in this form. Here you can see this is nothing but a quadratic equation in x, okay, and here in question only they are saying that if x be real, they are already saying x is real, prove that this cannot lie between 5 and 9. So we took this to be y, then we simplified it, we got this in as a quadratic equation in x, and they are saying that x is real. So x is real means what? Discriminant will be greater than equal to 0. Yes, so for this quadratic equation, discriminant is greater than equal to 0, that means b square minus 4ac greater than 0. So for this quadratic equation, what is b? B is 2 into y minus 17, and your a is 1 minus y, your c is 7y minus 71. Okay, substitute those values. Okay, now you calculate. Okay, and at the end you get 8y square minus 112y plus 360. Now do the factorization, you get this y minus 5, y minus 9, already minus, nothing to do. Now you have to write in ascending, so 5 9, so draw the number line and 5 9, done. Okay, do this. Now look which interval is positive, which is negative. Okay, so here 0 is in this interval, if you see. Okay, 0 is less than 5, so 0 is in this interval. So in place of y, if I put 0, then what I get? 0 here, 0 over here, so minus 5 into minus 9, so it's positive. So plus, then this is minus, then is plus. Okay, we are looking for only those values of y for which your left hand side is greater than 0 or equal to 0. So for which interval it is greater than 0? For this, anything less than 5 or equal to 5, because here equal to sign is also there, and for anything equal to 9 or more than 9. Okay, so here y will be in this interval, minus infinity comma 5 and this rectangle. Okay, because 5 is included, union, then this rectangle bracket 9 comma infinity. So clearly you saw that y was what? Y you had taken to be this, you had taken to be this value of this, you had taken value of this to be y. Okay, and you can clearly see that your y is not in between 5 and 9. Your y is either here or your y is here. So that way you have shown that y does not lie between 5 and 9. That means you have shown that this expression cannot give you value between 5 and 9. So that's how you prove. Done. So question number 14.2 is homework for you. Please do it. This is also homework for you. Question 20. If x be real, find the maximum and minimum values of this. If x is real, then find the minimum and maximum values of this. So for this, what you have to do is put this equal to y. Then same way as above, cross multiply. Okay, simplify. You will get a quadratic equation in x. Done. They are saying that x is real. That means discriminant is greater than equal to 0. Done. You know b square minus 4ac should be greater than equal to 0 for real. Yes. Now put value of b. Here b is this. Put the value of a, c. So here we have got. Now calculate, and at the end you are getting this y square plus y minus 20. Now factorization gives you this y minus 4 into y plus 5. I told you that plus should be written in minus and ascending order. So y minus 5 into y minus 4 less than equal to 0. Done. Now number line minus 5, 4. Now where does 0 lie? In this interval. So let's put 0 over here. So I get this plus 5 here minus 4. So it's coming negative. So that for this interval it's negative, for this positive, then this. If this negative, then this positive, negative, then this positive. We are looking for only those values of y for which your left hand side is less than 0 or equal to 0. So that means y has to be from here, this interval, because this interval only gives you negative. Okay, here equal to sign is also there. So minus 5 and 4 have to be included. So we can write minus 5 less than equal to y less than equal to 4. Okay, and y belongs to this. Okay, so y was what? Y you had considered to be this. This expression was y. Okay, so you can see that y can be 4 maximum or y can be minus 5 minimum. So you got your maximum and minimum value for that expression. So maximum value will be 4 and minimum value will be minus 5. So this is how we complete this chapter. Okay, so this chapter is also done. So this is all for this chapter.